with the remaining harvest, but it's has been underway for quite some time in many parts of the Midwest, and so this is a pretty familiar scene as you drive around. If we look at, first of all, just some general information, this is a collaborative effort amongst the state climatologists and several NOAA agencies and USDA climate hubs and the regional climate centers and the National Drought Mitigation Center. And our next outlook this webinar will be on December 20th and be presented by Becky Bollinger at Colorado State University. And you can access this and all the other seminars or webinars at drought.gov and also the MRCC and High Plains Regional Climate Center. So there's places you can go. So we'll talk today, and then pretty soon that webinar will be posted online. So we talk about links and maps and stuff. You can refer to those. So as Doug said, our agenda today is to look at recent conditions and impacts and outlooks and all that good stuff. And we had, amongst other things, one of the prettier sights in the Midwest in autumn is a little bit of frost, or in this case, some ice fog that's collected on plants. This is out of the Milwaukee office a couple of weeks ago. All kinds of great opportunities for fall photos out there. So I look back, if we go back all the way back to October, according to the National Center for Environmental Information, if we look at the numbers of the statewide average temperature rankings, basically the right half of the country was a little bit above normal. And in fact, if we go to the far northeast, it was much above normal, and several places in the New England area were at the warmest ever for October. Back here in the central part of the United States, it was above average in the eastern half and near average in the western half. So we just had kind of that strong gradient from west to east there of something close to average to something very warm out to the east there. Probably the coldest state in the central region that we're talking about today would be Wyoming, over there with a rank of 35. And most of the rest of them are in the top half of the distribution of warm Octobers. If you look to the year-to-date temperatures from January through October, boy, it's been warm all over. Let's see, we have the potential of 123 years of data here. So if you're 120, you're in the top 4 and so forth. So there's pretty much all of the central region was much above average for the year to date, and except for even some of the places like Kansas and the Dakotas, were not quite as warm, but still above average for the year to date. So if you take this U.S. as a whole, all of it's above average, and much of it is much above average. This is the statewide precipitation rankings for October, and for us in the central part of the U.S., we had many states were actually fairly wet in October. We had a couple of them that were very wet, like Iowa was 120, which would be the 4th wettest on record there. But we also had the wettest wettest October on record for Michigan. So it's at 123. And then you go over 4 states and you've got North Dakota, which was the 11th driest. So not everybody got rain in October, but there's big swaths of the central U.S. that got quite a bit of precipitation in October. So that's, in many cases, that was a turnaround from some drier conditions earlier on. And if you look at the year-to-date precipitation, there's a lot of blue across the U.S., so that's above average on the precipitation. There are a few states there in our region that were on the dry side, including North Dakota especially, but also Montana were on the dry side. But everybody else, there's a lot of blue, so many areas were above average, and some areas were much above average. In fact, once again, Michigan is looking to be on track to having their wettest January through October on record. So in the last 30 days, here's the average temperature departures across the central region. And the areas in green indicate areas that are below normal. So we have pretty much all of the central U.S. has been cool or cooler than normal for the last 30 days. The one exception has been over in Colorado, but everybody else has been much cooler than normal, and it's pretty widespread. If we look at precipitation over the last 30 days, we've got fairly dry conditions out west. If you go from the Rockies to across the high plains there, we saw very little precipitation in the last 30 days, and those areas in orange are only 1/10 of an inch. Looks a little greener as you move eastward. Areas in parts of Kansas, Missouri, and Iowa, and Wisconsin started to see 1 to 2 inches, and then it really got wet when you start looking at places like Michigan, Indiana, and Ohio, and Kentucky, and so forth. And as we'll talk here in a minute, so those areas that we actually saw some flooding conditions in the last 30 days. But very strong gradient from west to east there on the precipitation side. Now, if you look at the last 30 days in terms of as a percent of normal, you see a lot of red in the west there. Looks like a massacre or roadkill out there on the high plains, but there's a large area of very wet condition or very dry conditions. The amounts just weren't. They really just didn't have that much precipitation to speak of, and it was much below normal. When you get into the eastern portions there, you start to see from about the eastern part of Illinois eastward, you start to see the percentage-wise, the precipitation amounts get to be more sizable and are well above normal when you get in places like Michigan and Indiana, Ohio, and parts of Kentucky there. So big differences across the region. But by and large, most of the central U.S. was dry in the last 30 days. Talk a little bit about snowfall or expectations on snowfall. Here's the ballpark dates of the first measurable snow. So that's the first time you see at least 1/10 of an inch. So something actually measured with a ruler. Those dates typically hit in October when you're in the far north and far west, and then through the central part of the central region there. In many areas, it's November before you see that first measurable snow. And then if you're in this kind of the southern and southeastern part of the region, you really have to wait till December before you see that first snowfall. So that's kind of the expectation, and that's pretty much played out this year. We've got many areas that have seen their first snow. And some places actually have seen some accumulation of snow, especially in the Great Lakes region. Minnesota and Michigan and Wisconsin have seen a fair amount, and actually they're above normal for this time of year, although we're just barely into the snowfall season. But if you get 5 or 10 inches, that's enough to put you over into the above normal category in that area. And then you have to look farther west. So you look out in Denver and Wyoming and Montana. There's also some sizable snowfall amounts out there too. So in the 10 to 20 inch range out there. But everybody else, it's just been kind of hit and miss. I know here in Champaign, I've seen a few flakes on 1 or 2 days, and that's been about it so far. But that's where we stand on the snowfall. So very early in the season, but we'll see how that plays out. If you look at the snow depth, right at this moment, there's still some snow on the ground in North Dakota, Minnesota, Wisconsin, and the upper peninsula of Michigan. And then, of course, you also have all the snow out in the Rockies, so no surprise there. But so we do have some snow on the ground already at this point in time. Now, if you look back a year ago at this time, we had a totally different experience from what we've got this year. A year ago from now, we were very, very hot. We were talking about high temperatures, and especially in the high plains, of being exceptionally warm, and I think many places were setting and breaking records on many occasions there on the daily records. So very hot conditions across the Midwest and the high plains a year ago. So a big contrast to this year, where we're about 4 to 6 degrees below normal. And there we were about 6 to 12 degrees above normal. So a big difference in how things have played out in the last 30 days.
Hey, Jim, can I interject? I forgot to say one thing, and I want to say something else about this year compared to last year really quick. Sorry to interrupt. So we're as far as El Nino and La Nina and all that stuff, Jim's going to get to that later. But last year we were also more or less under a El Nino, or I'm sorry, La Nina sort of condition last year. Now it started a little earlier last year, but it was considered a very weak episode, which sort of fizzled as it went along in the winter. This year, we're also under a La Nina regime, if you will, in terms of equatorial Pacific. Again, Jim will talk about that a little bit more. But I just want to say, the reason I'm saying this is to show you that no 2 years, no matter how much La Nina or El Nino you're having, you can have these pretty wide variations, especially in October and November. We'll see more of its realization in sort of the winter season this year. The other thing I wanted to say is if questions come to your mind as we go through this, feel free to type them in the question area on the webinar thing on your screen. There's a question area so that we can look at those later and answer your questions either on the fly or at the end. I can also open up the phone at the end to anybody who wants to ask a question too. So you can raise your hand that way. There's a little way to raise your hand on the interface. Okay? Thank you. Back to you,
yes.
Jim.
Thanks, Doug. That's right. Yeah, this is a totally different experience from last year in terms of temperatures and snowfall and all that good stuff. So a lot different experience. I've already, my personal index is how many times I have to wear a flannel shirt to work, and I've done a lot more this year than I did last year at this time. If we look at soil moisture, as you probably know, we do not have an actual soil moisture network across the United States. Maybe someday. But in the meantime, we do have several models out there that try to model soil moisture. And and I just pulled up two of them here. They kind of showing similar patterns on the soil moisture of this area that really is from Arkansas and parts of Missouri and maybe spilling into Illinois that are still showing a lot of dryness in terms of soil moisture. And then we got a second area of concern up in the Dakotas and parts of Minnesota that also are behind or below normal on soil moisture for this time of year. Now the upside is that this is the time of year we typically recover on soil moisture. So it's the days are getting shorter, the crops are out of the fields, the temperatures are lower, and the evaporation rates are lower. So it's a lot easier to catch up on soil moisture this time of year. So many parts, especially many parts of the Midwest, will almost always catch up on soil moisture. It's a little harder in the high plains area, but they can still do it. So we'll see how this plays out here in the future. But we'll see what that does when we look at the forecast. This is Streamflow, which is another good way to measure the health of the hydrologic cycle. So we've got for the U.S. here from the USGS a lot of greens and blues across the central region. There are a few oranges and reds and some areas of typically the smaller rivers and streams that are showing up with that. A couple areas out there in Kansas and Nebraska and Missouri that are kind of showing up as some hot spots of below normal flow for this time of year. And kind of like soil moisture flows in the fall are kind of in the recovery mode. They're kind of on the upswing because as soil moisture and everything else recovers, so does the stream flow, and so those will probably be coming up. And a lot of this that we're seeing in the upper Mississippi River Valley and the Ohio River Valleys are a result of all those heavy rains. So we've got quite a bit of elevated flows in those areas. Let's see, in terms of the Drought Monitor across the central region, we've got some concerns down, especially in the Missouri area, where we've got everything from D1 to D2 down there in terms of drought. So that's moderate to severe drought. some lingering concerns in parts of Iowa, although it's kind of whittled away in recent months. And then we still have problems up in Montana and the Dakotas with some areas still in D3 or extreme drought. So the region as a whole, if the positive side is 67% of the region has no drought concerns at this point, but then 33% is in either D0 or some stage of drought. So we're about 2/3 okay and 1/3 a little on the dry side. If you look at the change over the last month, there's a lot of areas haven't changed too much. There's been some recovery, especially in Montana, and things getting a little worse when we go into Missouri. So there's kind of two areas that are pricing the most change in the last month or so, as you can see on the color coding here. So, and then in the eastern part of the region, there's been a lot of improvement, and that's just because of all the heavy rains of the last 2 months there. So we've had a couple of bursts of really cold air come into the region. So again, this is totally different from last year, where we really had very mild conditions throughout October and early November. In fact, I think many of us were still waiting for that first fall frost this time last year. And now we've had some areas that have actually dropped down to below zero. If you get up in the Minnesota and some of those areas, they actually dropped below zero a couple of times. And many places have been down into the 20s. So for the most part, what we call the growing season has pretty much come to a close for much of the central region, as we've had at least 1 or 2 doses of temperatures of 28 degrees or less. So, a lot of things start to shut down at that point, and that's certainly been the case this year. There have been some comments when we had in some of the discussions the other day that the impacts on fall leaf color has been interesting this year, between the combinations of areas that have been too wet or too dry or too hot or too cold. A lot of the fall colors have been kind of muted because they really like kind of a nice progression from warm to cool temperatures and not too much stress from being too wet or too cold or too dry. So this year we've had some odd cases of no color, and then at the last minute we get hammered by the very cold weather and the leaves just fall off, and with a little change in color. So a little bit of a disappointing fall color season in my opinion, but that can't win them all, I guess. But soil temperatures across the Midwest and High Plains are generally running in areas here in the shades of green are in the 45 to 55 degree range, and you get up into go north of there, you get into the blues, which are in the 35 to 45 degree range, and you get up into especially North Dakota and parts of Minnesota. They're already talking about soils that are starting to at least beginning to freeze during some of those cold snaps, and now I think they've kind of thawed out in recent days, but we're getting close to that time of year where things are going to start to freeze and stay frozen, especially in the northern parts of the central region. And for the rest of us, it's just probably the most important feature of the cooler soil temperatures, that you can do things like application of fall anhydrous ammonia, that you can apply the fertilizer and it'll actually stay in the ground without volatilizing there. So that's always a good thing to happen in the fall. So that's where we stand on soil temperatures. If we look at some events that have occurred, so we're going to talk a little bit about storms and the slow harvest. So back in October, we had, as they say in the song, when the gales of November came early, we had a pretty strong low pressure system move through the Great Lakes region around October 24th, and that produced pretty high winds across the region and some pretty high waves on the Great Lakes, especially Lake Superior. We had some areas that got up to the 25 to 28 foot waves, so that's pretty impressive. Those are the kind of waves that can take out ships. Fortunately, they were all sought shelter, so that was okay. But we saw a lot of soil or shoreline erosion and a lot of damage to facilities that were near the shore And many customers, especially in Michigan and Wisconsin, were without power because of the high winds from that storm. If we look at lake levels in general, while we're on the topic, pretty much all the lakes are above average on their lake levels, especially Lake Superior here on the upper left-hand corner. The blue line is what's going on right now, and the red line is what happened last year, and then the gray dots are the long-term average. So we're actually pretty high on all the lakes, and so when you have a storm like that, it enhances the damage that you can see from these events. We also had a tornado outbreak back on November 5th. We had a number of events, especially in Illinois, Indiana, and Ohio, about 21 confirmed tornadoes, and 5 of those were rated EF2, so fairly significant damage in some of those areas. So it's again, a little unusual to have tornado outbreaks this late in the season, but they do happen. We have seen those before across the Midwest, so this is it is noteworthy that we saw it in November. Getting back to the topic we've kind of hinted at earlier was the U.S. corn progress on the harvest. And this is a map of where we stand across the Midwest. So the primary number you're looking at is the percent harvested, and then the number in brackets is the change from the 5-year average. So for example, in Wisconsin, which has a darker color, only about half of the corn has been harvested, and that's 20% below the 5-year average. So we've got kind of many areas that you kind of would imagine, the areas that are very wet are a little behind on the harvest. And really pretty much the whole Midwest and High Plains there are behind on the corn harvest. And this is, we've had earlier discussions about this. It's kind of a multitude of factors. Some of the recent wetness has slowed things down. In some areas, we had delayed planting all the way back in the spring. And so the whole development process was a little behind.
Hello? Jim, are you still there? Dennis, are you there?
Yeah, I'm here, Doug.
Okay. Hey, Jim?
Oh, I just died.
Oh, now you're back.
I'm back? Okay. All right. So that was interesting. It just all of a sudden quit. So hopefully everybody can hear me.
Yes.
So we were talking about the harvest. So that some of the harvest problems were that we had very wet conditions in the last couple of weeks that slowed things down. But we also have a lot of issues with low commodity prices. Means that farmers are trying to dry the corn out on the stalk, and so it's not very conducive for doing that right now with the cooler temperatures and rain and humidity. That's made it much harder for a much slower drying process, but they're trying to avoid the drying cost of taking it to the dryer. So that also has probably played into the slow harvest of what's going on there. So several things going on with the harvest. So that's kind of so corn, for many places, the yields are good, what's coming out of the fields, but it's just very slow coming out. Soybeans the same way. Winter wheat, I think, is in pretty good shape across the whole region. I haven't heard too many reports of trouble. In fact, in many areas out west, they had some timely rains that helped moisten up that soil so we could get good germination and development of that winter wheat crop. So hydrologically speaking, if you look at across the major basins in the central region, the Missouri Basin, there's no major flooding. And the lower basin has been in really good shape, and the upper basin was dry, but it's getting better. So we had a lot of dryness in the Dakotas and Montana and so forth, but there's been some recovery up there. The Mississippi Basin has also had some recent rains that have eased some of those earlier low flow issues we had about a month or two ago. In the Ohio Basin, we've seen some flooding issues in the Ohio River Valley. Many of those related to the passage of Harvey a while back. So that does happen. We do see some tropical systems move through the central U.S. that can cause flooding even here. Here's the SNOTEL network out west. So if we look, if we look at Montana, Wyoming, and Colorado as far as what we are concerned about today, there's a lot of greens and blues, so that means the snow water equivalent is above normal for this time of year. Now we're very early into the season, so that's not representing much of a snowpack, but what it does say is that what we do have out there is at or above average. There are a few spots in Colorado, especially southern Colorado, that are below average, but the rest of the snowpack looks to be in good shape so far. So that's something we'll be talking about as we move through the winter. And finally, we'll talk about La Nina. So La Nina has arrived. According to NOAA, a weak La Nina event has developed in the Pacific since we last talked. And there's about a 65 to 75% chance that it will persist through at least this winter. It's probably going to fade off sometime this spring, but it's expected to be around for this winter. Probably not a really strong one, probably a weak to moderate event at this point. And you look at the La Nina probabilities here, so the bar graphs are what the forecasts are for this year. So OND is October, November, and December, so that's kind of where we are right now. And so there's over a 70% chance of it persisting through that period. And the bars stay pretty high all the way till February, March, April, and then you start to they start to drop off pretty rapidly. And so by next summer, June, July, August, it's very low. And so it looks like it's going to be pretty much a winter thing this year. And that's not unusual. The kind of the climatology of these events are that both El Nino and La Nina, that's these solid lines here, they typically show up in the winter months and they fade away in the spring, and then usually replaced by neutral conditions during the most of the growing season. So this is pretty much expected to be around probably through March, or the January, February, March time period, and then start to fade away. So the outlooks, we'll look at everything from 7-day out to the winter and spring seasonal outlooks. For the next 7 days, we don't see much precipitation happening out west. The western part of the central region there, that many areas have little or no precipitation unless you're up at higher elevations. But if you go eastward from about where I am, in fact, I got an X right over me here at 1.2 inches. If you go from Illinois eastward, we do have a system that's coming through that's going to produce quite a bit of precipitation in those areas. And those are the areas that probably are going to least welcome that extra precipitation at this point in terms of what we see in the rivers and streams, and also with the harvest. If you look at the 8 to 14 day forecast, so a little farther out on the left panel, we got temperatures. For most of the central region, we have an increased chance of being on the warmer than normal side. And also for much of the central region, we have an increased chance of being on the dry side or below average on precipitation. So there is an area of increased chance of being above normal up in Montana and Wyoming and North Dakota, but the rest of the region looks to be fairly dry. So warm and dry for the most part, unless you're in Montana. If we go on to the December outlook, it's not a very exciting outlook in terms of temperature for us in December. There's a small band of increased likelihood of being below normal temperatures out from Montana through North Dakota. It's not a very big area and it's not a very strong area, so it's kind of hard to put too much weight into that. But most of the central region is in EC, which is equal chances of above and below and near normal temperatures. There is part of our area, parts of Wyoming and much of Colorado and a chunk of Kansas there that are part of that broader band of an increased chance of above normal temperatures and across the southern part of the United States. Now for precipitation, it's a little more interesting. We've got this broad band of favorable for above normal precipitation, basically from the west coast, Oregon and Washington, all the way across the northern states to the Great Lakes region. And then we get an area in the southern part of the United States of drier than normal conditions. And so some of us are stuck in between there with the EC. But for the most part, probably the outstanding feature for the central U.S. is that band of increased chance of above normal precipitation across the northern region. We look at the 3-month outlook for our traditional winter months of December, January, February. Now they've got this area of an increased chance of below normal temperatures with a little stronger probabilities extending from Oregon and Washington over into Montana and the Dakotas and Minnesota there. So it's a little larger and a little stronger area than what they had when they had this forecast last month. So they've been strengthened that pattern a little bit there. It's kind of the classic La Nina signal in that region. And then we have this very broad band of increased chance of above average temperatures extending from California all the way to the East Coast. And many of the central region states are in that EC period, or areas, so we're kind of in between those two guys. So not much guidance there, or climate guidance one way or the other at that point. Now, precipitation, again, it's kind of a classic La Nina pattern with increased chance of above normal precipitation across the northern parts of the region from Montana all the way to the Great Lakes have very high probabilities, and then drier conditions in the southern U.S. So much of the central region has that increased chance of being on the wet side this winter. Now, we don't do a snowfall forecast, so it's a little hard to guess how that might play out, but those areas that are showing increased chance of below normal temperatures and an increased chance of above normal precipitation, you might conclude that those are areas that might see a lot more snow. As far as the March, April, May, which are traditional spring months, we see that area of increased chances of below normal temperatures really kind of hanging out there in the upper plain states, and then the rest of the area we see this broad band of increased chance of above normal temperatures. That's kind of expanded from the winter time. So you get into spring, that those areas start to push into Colorado, Kansas, Missouri, and points eastward there. So that's probably the big difference between winter and spring. Was this larger area with increased expectation of being on the warm side. And on terms of precipitation, we still have that La Nina pattern going where it's wet across the northern states and in favorable conditions for wetter conditions across the Great Lakes too. So that's, again, kind of a typical La Nina pattern that we see. And then dry conditions in the south, including Colorado there. So Colorado is a warm, dry spring. Many parts of the upper Midwest are going to see either cooler or wetter conditions during the spring. Look at the seasonal drought outlook as we get close to the end here. We have several areas that are showing drought persistence in the areas, parts of the areas in Montana and the Dakotas are showing a persistence over the next 3 months, and then that area that included Missouri and Arkansas, that area is also expected to persist. So those are the two areas that I think they'll be hard to get rid of that in the next couple of months. And some of that, if you go back to the maps, some of those areas that, like the Missouri one, is either in areas that were going to be EC on the precipitation, and in many cases were increased chance of being on the warm side. So it's a little harder to catch up when you're in those kind of situations. So, but that's we didn't have a whole lot of drought in the central region, but what we do have, they think is going to stick around for a while. So in summary, on the conditions that we're observing right now, the big takeaways are that we have colder than normal conditions across the central U.S., except for Colorado. They're the one warm spot, and that's a big contrast to what we saw this time last year. And basically dry in the western two-thirds of the U.S. or the central U.S., and with drought worsening in Missouri, and then very wet in the eastern third of the region. So kind of a contrast there on the precipitation side, and above normal snow in the Colorado, Wyoming, Montana areas and the Great Lakes. And we've got a La Nina advisory, which means we do have one right now. And there's a good chance of that persisting through winter, but it's likely to return to neutral conditions by late spring and on into summer. December wetter conditions are favored in the northern states from Montana to Michigan, and really not much to say on temperatures. And for the winter conditions, colder conditions are favored from Montana to Minnesota, and then wetter conditions across the north and the Great Lakes. So this winter may be a little different than last winter, which was kind of quiet and boring. So it might have some more excitement this year. And for further information, we've, as I mentioned earlier, we do record these and save these for the ages at the regional climate centers. And here's some other links to some of our other partners' websites. And you can find those when we post all this stuff on the web. And then today we've got a couple experts on the line to help answer questions. And with that, I think I'll stop here and turn it over to Doug.
Thank you very much, Jim. Feel free to write your questions in or raise your hand or whatever. I'm kind of scanning through here. I do have a couple extra things to maybe show you that I forgot to send to Jim this morning, and I meant to. Let me just pull them over here.
You're holding out on me.
I did hold out on you because I thought after I sent you my comments about your presentation, I thought, oh, you know what, these kinds of things would be interesting. So do you see my screen?
Yes.
Okay. So I'm not going to take any credit for this. This is something that Mike Halpert from the Climate Prediction Center put into one of his presentations. But the thing I want to show you is this is what we call a composite of what La Nina has done in the past, and there's a list of all of the years that fell under the La Nina regime or whatever, had a La Nina signature through, I believe it's December, January, and February. Yeah, December, January, and February, which is when we see a lot of the effects from El Nino and La Nina. Anyway, this is a La Nina, what we call La Nina composite. Those are all the years that it happened. The coloring shows where temperatures were above and below normal. Okay, so you'll see in the high plains there's a tendency, as you saw in the forecast, there's a tendency for cooler than normal conditions to the north, and to the south you see warmer than normal conditions are often realized. So that's blending a whole bunch of La Ninas since about 1950 till now. It doesn't take into account their strength or anything like that. So I'm going to show you another map. Let's see if I can get to the next screen. Here we go. These are also composites blending La Ninas, but now we split them out. There's those previous to 1985 and those after 1985. Okay, and then you'll see the tendency is a little bit different than it now, if you will, since 1985 to what happened before. Okay. So before 1985, there was a pretty strong signal. If it's going to be a La Nina, and pretty good chances it's going to be colder than normal across at least the upper tier of states. And I think this is a fairly interesting thing because since 1985, that hasn't been realized as much. And you can see the warmth sort of expand across the southern part of the U.S. So that might be something you take into account, or we take into account, I'm sorry, let me go back to that. We take into account when we look at outlooks now. And then as far as precipitation, it's a little bit different and not as strong of a signal unless you live in the southern part of the U.S. All that yellow area has a tendency to be drier than normal. Again, this is only December through February. So that area tends to be drier. And this is again, since 1950, all La Niñas blended together. You see the Ohio Basin and Great Lakes have a little bit of a signature of wetter than normal, and you also see in the some of the, I guess, upper elevations and higher areas in the west and along the west coast from Oregon to Washington being wetter than normal as well. And when you break that down and split it out, you do see some differences prior to 1985 and after 1985 in terms of the precipitation signatures. Generally, the pattern is pretty similar. Some dryness, some extra dryness, if you will, may be showing up in the southeast. In that Ohio region, maybe a little less strong in terms of certainty, in terms of being wet. Same in the northwest. Okay, I just thought that might be an interesting thing to add to this conversation, because we often do that sort of composite, but we use all of them for the whole period of our period of record, which is about 1950 till now. I mean, yeah, for these things. So just thought that might be interesting for you to see. Let's see if we have we do have a question here. Hold on. Paula Pesto asks, is there a reason for the difference in the impact of a La Nina system on temperatures since 1985? Yeah, you know, generally the simple answer to that, and maybe overly simplified answer to that, is that the climate has warmed a certain degree, and it's just not showing up as cold. We're not showing those cold tendencies as much because there's not as much cold air, and we just don't have the same. The climate has changed since then. In 1985, 1975 to 85, and there often is sort of a breaking point for a lot of changes that we see, climatologically anyway. Anybody else want to? Dennis, I'm sorry, I didn't introduce Dennis Toddy. Dennis Toddy from USDA Climate Ag Hub out of the Midwest is also on the phone. I don't know if he has any comments, or Jim along those lines.
Nothing else to add. Okay.
Yeah, now we're getting lots of questions and comments. Oh, sorry about that, everyone. Okay, hopefully it answered your question, Paul. And do we know the sensitivity to the year of the breakout, for instance? This is from Aaron Wilson, so he's a climatologist, so this is going to be one of those questions that I'm going to shift over to my friends. Do we know the sensitivity of the year of the breakout? For instance, do the events on either side of 1985 drive the difference in composites? I don't know. I don't know that, Aaron. No one, to my knowledge, we haven't studied the strength. I'm sure people have, but I don't know where to find that information. It'd be a great study to do. We'd like to see that. The problem is, since 1950, as you saw there, we may have, I don't know, 15 or 20 episodes, maybe a few more than that, of La Nina to work with, which really doesn't make a great sample in terms of a statistical sample. So it's really tough to say much more than just show you the maps, show you the difference, and not say that this is going to happen, because that's not a prediction. The prediction is what the Climate Prediction Center said. But just to show you the tendency or the trend, it's a bit more of a trend in how La Nina has realized itself over the U.S. And I got a thanks there from Ted, and then I suspect the composites of, I'm sorry, any other comments from Dennis or Jim on that last?
No, I think that's good.
Okay. I suspect the composite of ENSO impacts has changed over the years as well. Okay, that's somebody else's comment. I can't move this thing. Okay, here we go. That's why we have models. Thanks for your response. Okay, all the rest are comments. Any other questions? Or let me see if there's any hands up here real quick for anybody who wants to speak out. Oh, Becky Bollinger is going to tell me that she feels like a lot of the differences in the composites is that they're both compared to both compared to the same average, right? if you compare the older La Nina events to an older 30-year average, the map might look similar, or even, well, actually, it might even be, yeah, it'd be interesting to do that, actually. Becky, do you want to actually say that, what you're saying to me? I'll unplug you here, so to speak, or plug you in. I mean, that's a better way to say that. Go ahead, Becky.
Can you hear me?
I can.
All righty. I guess my feeling is because of our warming climate, and we're seeing some warming in each of our 30-year averages, that since we're using our most recent 30-year average, if I took a composite of a bunch of years prior to 1981 that were El Nino or La Nina or neutral, you might see a lot cooler than average anyway, because you're comparing to such a warm average. So I just wonder if a lot of the signal you're seeing there is just simply comparing to the 1981 to 2010 average, and if you picked a more representative average for those older La Nina events, if it would look pretty similar, like you would have the warm signal to the south, but maybe not much of a signal to the north. I don't know for sure. I'm just surmising.
Yeah, I think there'd still be a trend, a possible trend there, but you're right. It really does depend what 30 years what consistent 30 years we compare them to. In the climate world, every 10 years we update the averages. We update the averages to reflect the last 30 years. So in 2020 or so, we'll have a new 30-year average to compare to what we consider our climate now. 71 through, 2000 was our previous one. Now it's 81 through 2010, which was actually made a few years ago. But yeah, it does matter how you which 30-year period you do compare it to. Any comments, Dennis or Jim?
No, I think that's very true. We tried to do a study a long time ago with some of the earlier El Nino and La Nina events, and yeah, that's a very difficult problem to address because you're trying to hit a moving target, and your definition of El Nino and La Nina is relative to the average or quote normal ocean temperatures at the time. So it was a bigger problem than I expected it to be. So.
Yeah, and we had another question about the source of the data for the composite maps. First of all, I'll address the second question, which is what are the boundaries shown in those composites? And those are climate divisions, which were constructed, God, I don't know, many years ago across the United States, and they are ostensibly, for the most part, when they were created, they were supposed to take into account surrounding areas that were similar in climate. Jim and Dennis, do you want to enhance that a little bit?
They're older than we are. Enough said.
Oh, did I? I took my presentation down, didn't I? I'm sorry. I didn't mean to do that. Yeah, so those are climate divisions. Again, it's something we climatologists use. No, they're not counties, and they are not necessarily based on anything on the ground. However, when you get to continental divides and things like that, it certainly makes sense to use a continental divide, right?
Now, Doug, you should note that in the West they do follow more river basin drainage areas than they do in the middle part of the country.
Right. And then in the source of the data, I think is simply ground temperature and ground precipitation station data that we have a long period of record for. Those composites anybody can make, by the way. There is a website to go and play around if you'd like. It's fairly technical, but it exists. Can someone send that if they know it off the top of their head? Otherwise, I have to go find it. I'm sorry I did not include that, but it's with the Earth Systems Research Lab, which is part of NOAA, the Physical Sciences Division, which is part of NOAA, out in Boulder, and they have lots of really kind of neat tools to fiddle around with things. Of course, that that means you'd have to know what years are La Nina. If you want to look at El Nino and La Nina, you'd have to know what years are officially those, and that's another website you might have to go to figure that out. So what I would recommend, if you're not a climatologist, yes.
I just shared it with you.
Okay.
You'll have to share it with everyone else.
Oh, okay. How do I do
on the chat?
Yep, on the chat.
Oh, you put it on chat. Can everybody see that?
No, they can't. It's only you.
Oh, okay.
Share it.
How do I do that?
Copy it and paste it. Doug, there's one more thing I think it bears repeating about these composites. The things that we know that also influence La Ninas are the strength of the La Nina, and then other intervening factors like the Arctic Oscillation, North Atlantic Oscillation. There's a couple other ones that influence here. But the problem is that when you start trying to subdivide these categories of La Ninas too much, you get very small sample sizes.
Right.
So that's why we tend to kind of throw them all together and say, here's what it looks like. We know there's lots of variability to it, but you know, subdividing sample sizes gets kind of nasty.
That's right.
So if for a recommendation on who to contact locally, sometimes the weather forecast offices, your National Weather Service forecast offices know a lot about this stuff. Your state climatologist, like Jim Angel in Illinois, would be a great guy to go to. They know quite a bit about that, and so I see that I have 5 minutes. Someone else is going to take over my meeting here. So anyway. I'm not going to start the meeting quite yet, but they may. So I hope we answered all the questions.
And Doug, this is Jim Angel again. I just wanted to correct one thing earlier. I may have painted a little too rosy a picture on the winter wheat conditions.
Yeah.
In South Dakota, anyway, I think there's a pretty rough shape. Only about 14% of the crop is rated as good to excellent. Most of the other states actually look pretty good. It was just South Dakota that's a little on the rough side right now.
Thank you so much, Jim, and thank you, audience, for the great questions. And I hope it wasn't overly confusing. We'll try to confuse you again later in December, where Becky, who actually made the comment, will give us her outlook and presentation from the state of Colorado. Actually, is where she's from. She'll be looking over the same region. So thank you, everyone.
Quick clarification, Jim Angel's first slide showed that webinar being on December 20th, but I think it's the 21st. Is that correct?
I'm trying to look at a calendar real quick. The answer is it's the third Thursday no matter what Jim says, so the 21st. It is the 21st. Yeah, geez. Yeah, we don't get off early for Christmas. No early for Christmas, Jim, sorry.
Yeah.
All right, thank you, Becky.
Celebrate the winter solstice.
All right. Thanks all, and we'll see you next month. Goodbye.
All right, thanks.